Hello, my name is NXT. See that box over in the corner? That's where I live. Please adopt me. I can help out around the house, cleaning and such. Actually, I will do anything you ask. Here, let me tell you about my life. Robots serve a variety of purposes in society. The robot has become indispensable, one that society truly needs. Champions for the cause have identified various services that robots can perform to ensure a safer workplace. They perform the dull and repetitive, yet incredibly accurate motions required by industry. They are able to seek, search, and diffuse dangerous situations for the armed forces and explorers alike, and they can lessen the impact of disease in the sanitation and healthcare fields by performing dirty and unhygienic jobs. If we expect students to become productive members of society, then it is paramount that we expose them to robotic technology during their formative years. So, the question becomes, how do you systematically integrate robotic technology into education and the minds of children? The Lego Corporation, already experienced at sparking children's creative imaginations, looked toward the future. They realized that robotic technology was rapidly enveloping how adult engineers think and design. Therefore, they believed that children, well-versed in snap and build Lego systems, could benefit by engaging in electronic applications too. The result was they incorporated brick technology, developed in 1994 at the University of Colorado, into the first RCX Lego robotic brain. The target audience for the Lego robot is children ages 10 to 14. Lego, however, did not want to limit the appeal of the technology to a specified age group. They wanted to create a device that would grow with the child. This meant that the programming language had to be simple and user-friendly, yet capable of advanced logic. It was decided to use RoboLab, programming software that was developed at Tufts University. Another hallmark of Lego is tough, interchangeable parts. It was deemed necessary that the parts used to construct the robot could interchange with existing Lego products, blending the familiar with the innovative. Originally, through a partnership with MIT, the Lego Mindstorms kit was made commercially available in 1998. The new NXT version was made available in July of 2006. Initially coming with 2 motors and 3 sensors, the kit now contains 519 Technic pieces, 3 servo motors, 4 sensors, 7 connecting wires, a USB cable, and the NXT brick, or brain, of the robot. The kit is marketed online and in catalogs at a cost of less than $300. It has also been given exposure in schools and through the first Lego League competition. In 1921, a Czech writer first used the term robot in the title of a play. The word was derived from the Czech word robota, meaning forced labor. Yet it was not until 1961 that the first industrial robot was put to work on a General Motors assembly line. This, along with Seymour Papert's 1980 seminal work, Mindstorms, Children, Computers, and Powerful Ideas, represented the initial phase of the innovation decision process. During this time, the knowledge of robotic technology was first realized. The persuasion process began in 1990 when Lego was named one of the top 10 toy companies in the world. With its newfound place in international business, Lego now had the clout to partner with the University of Colorado to develop the first computerized brick. Then, in 1998, they partnered with MIT to market the robot. Shortly thereafter, the first Lego League competition was formed to encourage robotic technology in schools. The implementation of the technology was highlighted in 2006 when the NXT edition was released. An enthusiastic crowd of 80 robotic teams from 30 countries converged on Atlanta, Georgia, providing further proof of diffusion. Ultimately, the technology was confirmed by expanding the product in 2008 to a new line called We Do Robotics, intended for a younger demographic. Although personal communication channels, both on the internet and by word of mouth, have played a part in diffusing robotic technology, the primary method has been through the mass media hype surrounding the first Lego League, an Olympic-type event for middle school students. FIRST is an acronym for Inspiration and Recognition of Science and Technology. It is a worldwide technology tournament where children build robots to compete in problem-solving challenges. The enthusiasm for the first LEGO League is a clear indicator of how quickly robotics has been adopted by schools. In 1994, LEGO first experimented with the RCX brain. By 1998, FIRST was formed, and in 1999, 9,500 middle school-age students attended the event. The following year, there was 15,000 participants, then 18,500, 27,000, and 42,000 in each successive year. During this period, critical mass occurred as the adoption rate became self-sustaining. From this point forward, the early majority adopters began in earnest. By 2004, the event had grown to 50,000 attendees. The number jumped to 60,000 in 2005, 90,000 in 2006, and by 2007, close to 110,000 students attended the event. The S-curve provides evidence that the technology has yet to plateau. It is still an expanding media. Introducing the LEGO Mindstorms NXT robot. The earliest adopters of LEGO robotic technology include middle school students and educators with a deep and abiding interest in science and technology. Often, the talented and gifted classes are used for trialability groups with the schools. As teachers begin to realize the curricular benefits and relative advantage that the technology provides, and as students experience the simplicity in construction and programming, and as their peers begin to hear about and observe robots venturing around the school, then interest will surely spread. The most likely source of laggards in the adoption of robotic technology would be students and educators in poor and underachieving schools. They would likely consider robotics to be extravagant and unnecessary. Financial underwriting, compatibility with curricular goals, and demonstrations of real-world applications to include summer camps and after-school activities will be needed to encourage adoption for this underprivileged segment of the population. The adoption of robotics in education favors a centralized approach. The robot represents a specialized device developed by engineers. Adopters depend upon specialists to promote and demonstrate their product. This is accomplished from a top-down approach where experts pass the knowledge down to the local adopting units. While the continuum leans toward center, some decentralized elements such as modeling and reinvention will also have an effect on diffusion. The LEGO Corporation has developed a network of regional resource personnel that serve as change agents for the industry. These individuals help identify the need for the product. They seek to develop an information exchange system. They diagnose problems. They instill interest. They provide a hands-on approach to encourage adoption. And while always available to answer questions, they distance themselves from the adopting unit by encouraging independence and confidence in purpose.
Domo arigato, Mr. Roboto. Domo arigato, Mr. Roboto. Domo arigato, Mr. Roboto. Domo arigato, Mr. Roboto.
The following websites are recommended for additional sources of information regarding robotics in education.